Hello, welcome to the NGINX Sprint session, Automate Application Security with NGINX. My name is Chris Witeck. I'm a director with the NGINX Application Security team, product management team here at NGINX, and I'm joined today by Daniel Edgar, who's also on the NGINX App Security product management team. And where are we at in our NGINX app modernization journey? Well, we are at the Automation Application Security with NGINX part of the session, as we just talked about. Before we jump in and go into the details and how you can automate application security with NGINX, I want to do a brief overview of the NGINX security offerings that are available. We've had quite a few new offerings come out in the last 18 months. A lot of you may not be familiar with that. So why don't we go in and just dive into what is the NGINX approach to security. So NGINX is investing in quite a few different security solutions and options that can be implemented by DevOps teams and SecOps teams and used within your pipeline. Solutions that make it easier for you to secure apps in a wide range of environments without having to trade off performance for security. Our goal is to provide you and your security teams choices and flexibility in where you can deploy security. We want to be able to provide DevOps teams and DevSecOps teams the ability to deploy security specific to an application or specific to your APIs right by the applications or the application services, but still provide the ability for your infrastructure teams to have choices in how you secure infrastructure and groups of applications. In reality, between the portfolio of security offerings from F5 and NGINX, we want to give you choice and have the right type of flexibility to deploy security when and where and how you want to. We also want to provide you with the ability to provide your dev teams with security guardrails and guidance. And what we mean by that, this is something we hear consistently from our customers. The DevOps teams, they want guardrails, not gates from security, meaning provide the appropriate level of guidance and tooling on how to insert security into their pipeline versus doing any type of interrupt-driven process, any type of gate that drops, any times the security team wants to have a review or a conversation. What we want to do is we want to help make security everybody's responsibility and make it as easy as possible to implement as part of your pipeline. Now let's talk a little bit about some of the products that are available. So everybody should be familiar with NGINX Plus. NGINX Plus is loved by dev teams because of its flexibility. It's all-in-one approach to reverse proxy, API gateway, load balancing, and a lot more. And there's actually more to that story. We are regularly looking to how we can layer on additional value for NGINX Plus, with recent efforts centered around traffic management for Kubernetes environments. And in the last 18 months, we've added in security options as well. So we've added in the NGINX App Protect family of products, which consists of a NGINX App Protect for WAF, which is a web application firewall, and NGINX App Protect for denial of service, or DOS. And really the focus here is to insert security that is based on F5 technology, based on F5 IP, but built and optimized for modern app architectures and built and optimized for your CI/CD pipelines. And there's more to the story than that as well. We also have NGINX Controller. Now, NGINX Controller is really oriented towards the large distributed organizations, providing you the ability to standardize and simplify the deployment of and security of your apps and APIs. It allows you to take a look at insights and metrics on a per app and per API basis. Allows you to delegate services out to your development teams so that specific dev teams have governance and guidance in how to insert security as part of deploying their applications. And let's drill in a little bit on the security capabilities of NGINX Controller. So the first layer of that NGINX security is really around securing modern applications. And this allows you to insert security policy lifecycle management that can be deployed and automated on a per app or per API basis. And this is based on NGINX App Protect, the same security product we mentioned before. NGINX Controller is really abstracting the need to manage the data plane, NGINX Plus and NGINX App Protect, and really aligns it as part of that lifecycle management. The second part of the story is intelligent insights, and really allows you to orientate information about the security efficacy of your applications, how you're securing your applications on a per app and a per API basis. And how we do that is really based on the third area, which is the self-service model. We can empower your development teams to have the appropriate level of guidance provided by your security teams, but pushed out to your development teams. So they have the information they need. They have the guardrails they need to insert security for the applications that they are directly concerned about, that they directly manage. So that's really a high-level overview of the security offerings from NGINX. Now I want to hand it over to Dan, who's going to go a little bit deeper and talk about specifically how you can automate security with NGINX. Over to you, Dan.
Thank you, Chris. So that's a lot to think about in terms of NGINX and the product offerings in relation to security, specifically application security. But how do we get there, right? It's security is more of a program than a product that you buy per se. So what we want to talk about today is how you might integrate some of the tools and technologies we talked about on previous slides that Chris mentioned, specifically NGINX App Protect WAF and our denial of service product, into your security programs. So you may have heard of DevOps, but have you heard of DevSecOps? If you want a simple DevSecOps definition, it's really short for development, security, and operations. And it's defined by its mantra. Its mantra is to make everyone accountable for security with the objective of implementing security decisions and actions at the same scale and speed as development and operations decisions and actions are made. The scale and speed statements imply structured automation, which is going to be a key part of this demo you're going to see today. So in practice, what does it look like? Well, what you're going to see is I'm going to show you on the screen a typical DevSecOps workflow. There's going to be pre-commit activities that occur, and maybe while not centrally automated, they're an important part of an application security program. The next step, here we have displayed on the screen there, is our automated portion of the different activities that typically occur in a DevSecOps pipeline. So the next step that occurs there is that commit time check and the associated activities with it. And these might be automatically triggered by a check-in to a source code repository. Then we've got build, the third activity in the pipeline, which is automatically triggered by successful commit time tests, the previous set of actions. Then moving down the pipeline, test phase checks are successors to the build time tests. And if all the previous steps have been completed successfully and the application is ready for deployment, deployment and smoke tests finish out the pipeline. Now, let's look at some of the sub-activities associated with each of these phases. We won't go into great detail immediately, but I wanted to offer at least a high-level overview of what they are. And please note as these unfold that the sub-activities indicated in red are related to security practices. So under pre-commit, you might see a security practice called threat modeling, using methodologies such as Stride in order to generate insights about an application's security exposures and vulnerabilities. Then you might have a manual code review process. An extra set of eyes on the code or pair programming techniques is vital to making sure that you deliver a quality solution. Then at the commit level, you might have a code quality automated scanning. It might be doing linting, it might be looking for design practices, performance suggestions, and whatnot would appear at this phase. Also with unit testing. So at a component level, automated tests that individually in isolation test pieces of your application. On into the build phase, obviously you're going to build. If your application is in a language that needs to be compiled, that's going to occur. If you're wrapping your application into a container, as we're going to see in today's demo, you're going to be building containers at that phase. But then there's a notion of static application security testing at this point, where we're really analyzing the code, analyzing other things that are going on associated with it, looking for potential security vulnerabilities. And those are very popular additions in a mature security-enabled automation pipeline. Then you might, if you're dealing with containers, obviously, they're going to have their own potential vulnerabilities. So we want to be able to scan those containers to make sure that we're not using any packages or libraries or other tools that have been indicated to have vulnerabilities associated with them. Next step, testing. In my environment, I've got a stage and a prod environment. So obviously we want to deploy to the stage environment or user acceptance testing environment to do the next phase of our testing, which might be automated functional testing of our application. In our case, it's a web application. But beyond that, we're going to introduce DAST, Dynamic Application Security Testing. We're actually scanning the application from its interface or its APIs at runtime to see how it behaves, to see if there's any vulnerabilities associated with it. Then finally, if everything to the left of that has been successful, we are going to deploy out to our production environment. We might do a smoke test or final test in the environment. And most importantly, indicated in red here is what I did, monitoring. We want to know how people are using the application to make sure we have appropriate capacity, but we also want to know how people might potentially be misusing or abusing that application and have very quick or low latency notifications of those kinds of activities, which is important in an operations phase. So what about our demo pipeline? I'm going to use this overlay, but I'm going to put in specific tools and technologies that, again, this isn't a prescription and we're not playing favorites, but that you're going to see in this demo and options that you can use to put together your first DevSecOps pipeline. So we're going to be using as our source control manager, GitHub. And along with that, we're going to be using GitHub's GitHub Actions, which is essentially their automation framework that integrates very well with GitHub. We're going to use a tool called CodeQL for both, it's straddling too, but for both code quality checking and SaaS testing. This was originally a Visual Studio extension, but Microsoft acquired the technology. It's not pictured here, but we're going to use a container registry called Azure Container Registry, which I'll show you in the demo. We're going to be performing container scanning and linting by using a couple tools called Trivy and Dockle, integrated into an easy-to-use GitHub action. Our test and production environments, I should mention, are in Azure, deployed in Azure Kubernetes Services namespaces. But next up we have, as shown on the screen there, Selenium for our functional or automated functional testing. For the DAST function, we're going to use a free real-time active vulnerability scanning tool from the OWASP Foundation. Those are the folks who brought you the very ever popular OWASP top 10 list for application security vulnerability prevention. All right. And then finally, monitoring. We're going to use Elk Stack. So it's Elasticsearch, Logstash, and Kibana in a container to view application access, WAF events, and denial of service metrics. All right. A little bit more about our environment and our application. Our application consists of two pods. On the right, it's going to be Microsoft.NET web application, just a demo, fictitious web application that you're going to see the code for, as well as a pod running a container of NGINX Plus as our proxy server, and NGINX App Protect web application firewall and denial of service module. So that represents our production environment, but also you're going to see that in our staging environment. These environments are isolated from each other thanks to Kubernetes namespaces that we're going to deploy into, but they're also like in terms of feature parity and compatibility. With that, we're going to begin our demo showing you what a DevSecOps pipeline looks like. So to start off our demo, we're going to be working within our IDE as any developer would. So I am using VS Code by Microsoft, and I've got my solution workspace. And let me give you a quick tour of that. I've got a GitHub folder, which contains our workflows that we're going to be using for our pipeline. It's nice that they're right here with our application code and our proxy configurations. I've got an App Protect folder, which has the container building information, the policy file expressed in JSON for our application, our security policy, as well as our .NET Core web application and the pages it contains within them, right? So what does that workflow look like? Well, it is expressed as YAML by default with GitHub Actions, and it's a list of jobs and builds that break down into smaller steps that contain actions to run each portion of the pipeline. Now, obviously, this is pretty dizzying, so I'd much rather show you what this looks like using the GitHub user interface. Once I have committed my project, as I have previously, I can go to the Actions tab in GitHub, and under there, I have my pipelines showing. Our main pipeline is the DevSecOps pipeline. And you can see that I've run this workflow a few times before, triggered by earlier commits. I updated an application title. I had to update a test that failed after that, and so on and so on. But within each specific run, I can go look at the details associated with that. And in very human readable format, I can look at the different steps and if they were successful or if they failed as part of that workflow, right? So that's a basic quick tour of the workflow. I want to also show you, I am using the Azure Container Registry product. I have pushed up images of my NGINX proxy and WAF combination container, as well as application-specific containers and the application-specific policy associated with that proxy. The top two containers we will be deploying to Kubernetes. And speaking of Kubernetes, we're using Azure Kubernetes services. Here's my cluster. Here are the workloads and services deployed to that area, as well as the ingress services, right? So what is this application I was talking about? Well, it's really a simple and frankly ugly application demonstrating very at a high level that we have code that's running, that's executing, and it is displaying to the user and being served up by the proxy you saw in our environment slide before, right? It really doesn't do anything. It's got a couple pages, it's got privacy, it's got a file upload feature, and of course a home page. And we're going to be modifying the code associated with this. So obviously this search doesn't do anything right now. And my product owner is on me saying, you know, this is not good enough. Sorry, it doesn't do anything. I want to display back the contents that the person was searching for, and then display the search criteria, or sorry, the search results based on top of that. So I need to add a feature clearly. So I'm going to bounce back to my IDE, and I actually already have that code written in the .NET Core web app under Pages. Here's the HTML associated with that. And I'm going to display the content associated with that search string and display it back to the user. We're going to come look at this again. And then I'm going to commit that. To GitHub. I'm going to commit it locally, actually, and I'm going to push it to GitHub. And then now that I have pushed it to GitHub, you may notice we are going to see that that workflow has been triggered in the action screen. So yellow means that it's actually working on that particular workflow associated with that commit message, add search display. And we're going to go ahead and look at this. It's in the build phase right now. Again, it's going to build, run all those tests in the staging environment. And then if all that's successful, it's going to push the same build to production. And these can take a little while, I'm going to be honest with you. So what we're going to do is we're going to pause and we're going to come right back at the end of the build and see how everything went. All right, as is common with developers, I went on a long coffee break. I'm coming back. I'm going to see how things ended up. And oh no, it looks like our build failed as indicated by the red X under that particular commit. What exactly happened? So we need to drill in and see what's going on. So it failed at the build stage before deploy prod. So it was something that happened in the staging environment. And I further drill in. Yeah, I went through all of these processes, pushed the containers, built the applications, but it failed at the DAST OWASP ZAP scan. What's going on? Okay, all these things passed. Very good, very good, very good. Okay, I've got a new error associated with a reflected cross-site scripting attack. Interesting. What else happened? Well, as part of this action, another cool feature about it is it automatically creates a GitHub issue for me with some details. So it can look at the scan report. It can look at the particular URL that caused an error, right? And here we see at the bottom, it says, yeah, I need to go ahead and fix this. So what was the error? Here's the details. It tried passing in a script tag to that script box. And what happened? Let's find out. So let's go see what it saw. I click on that link and it reflected that script back to the user's browser. That's a big no-no. And again, that's called a cross-site scripting reflected attack. And this is essentially what caused it. So if I was a user on the page, I would be allowed to put script in, save it, and then redisplay it to the user. And that's what the scanner caught us on, right? So that's a problem. So bad developer, I made a mistake. I really need to go and fix that. But fortunately, I have got my web application firewall, NGINX App Protect WAF, enabled in a transparent mode in line. So it can see this and intercept all that and block that. So a vulnerability associated with this doesn't occur. So how do we do that? Well, I'm going to go back to my IDE, Visual Studio Code. I'm going to go into not the application itself, but I'm going to go into the configuration of that NGINX WAF tiers policy. And that policy file, we started out in transparent, which means to monitor all the traffic, but don't actually do anything about it. Monitor the traffic, log it, and then, but work in a transparent way. But I want to go ahead and set that to blocking, right? Because this is obviously I want to fix my coding mistake, and I absolutely should, and I could do that at this point. But I'm going to enable the WAF, and we're going to see what happens. I'm going to enable WAF blocking. I'm going to commit that, and I am then going to push that change up to GitHub. I'm going to flip back to the actions page. And note that the build is kicking off again. Okay, let's go for another cup of coffee, and we'll see you back here when it's done. All right, back from my coffee break, and good news. It looks like the build went green. So drilling into that, okay, looks like the build was fine, and it deployed to production. Let's go look at that issue. That GitHub issue, it looks like it was revised. And look, the resolved alert cross-site scripting reflected has been resolved. So I know it keeps a log of that, and I no longer need to work on that sort of thing. So why is that? Well, let's go look at our stage environment, and let's try replicating that. I'm going to put in the cross-site scripting attack to see exactly what will happen in that environment. And I'm going to commit search. Okay, and we've got a custom WAF block page that I actually created earlier to show that that particular request has been rejected. So the fact that that was not successful, the OWASP Zap scanner, it satisfied that scan and it was able to move on. So immediately I've got some value out of my WAF just by enabling it, because that's a common kind of attack and something that's definitely present within many years of OWASP top 10 vulnerabilities published. So I see a support ID. What does that look like? Well, that's a correlation ID that shows, that it's a unique identifier for every specific block event. But where do these block events go? Well, I'd like to introduce you to the AppProtectWAF Dashboard in Elk Stack. So we talked about for monitoring stage, we are using Elk and a Kibana dashboard. And this is something we provide free, and we host it in our F5 Dev Central repository. It shows the kind of attacks that have occurred in this particular environment over a period of time. This was during my security scan. So obviously we're going to see a mix of alerts, which means we allowed it. It was only suspicious, but we also have blocked alerts, which that particular thing we just saw was a block. And I have some logs associated with that. If I wanted to drill down and I wanted to look at how the different attacks, the ways people might be using or misusing my application, the URLs they're using, top violators, that kind of thing. I have a sense of what's going on in my environment outside of development. Once I am operating the application, I have that kind of visibility, where attacks are coming from, and of course the details related to each of those attacks. This was mine, attack signature detected, violation rating threat detected, and as a result, it was blocked. That was what we saw up there in the browser. That was that particular event, right? So along with that, let's say associated with a release, we start to see a lot of blocked and alerted events that we didn't see before. We can also overlay, again, as part of having knowledge of when when our environments are updated and when deployments happen, correlate those. So I've got as an overlay again, a deployment to stage that happened at 15 after the hour, right? To stage environment. After that, it happened to production. So again, I have some insights to be able to help me develop that particular security policy, gain some insights on what might have caused a different behavior in my WAF posture. So I can, again, make changes to my policy, redeploy it as part of that automated pipeline, monitor, inspect, adapt, and repeat if I need to, all right? So this is the NGINX App Protect WAF dashboard. Since we're also using the denial of service dashboard, we provide that as well. And I can see events associated with the health of my application for a given period of time. So the AppProtect DOS product, as you may have heard about in another session at Sprint 2.0, it constantly validates and is reevaluating what normal traffic looks like on my particular application associated with business events. It also is monitoring the stress level of my application. And if it determines that the application goes into a state of unavailability or stress, it immediately will jump in and provide protection by redirecting attackers against my site. So my website stays up. I can continue doing business while thwarting attackers that might be trying to take down my website by making it not available. So that's just a quick tour of an additional benefit, because I have both AppProtectWAF and DOS in my pipeline and in my proxy container, but I can also monitor it again from a single pane of glass in my Elk dashboard. Well, with the completion of the demo, both Chris and I want to thank you for attending this session as part of NGINX Sprint 2.0. I have the GitHub repo used in the demo on the screen there. Please go ahead and fork it, contribute to it, extend it, steal it, do whatever you want with it. We want you to find some value out of what you may have seen here today. I want to thank RK Selvey in GitHub for the original DevSecOps template, project, and inspiration. And finally, you're going to see 2 product links to NGINX App Protect, Web Application Firewall, and Denial of Service modules, complete with their links there. Please enjoy the rest of NGINX Sprint 2.0.
Yep, thank you.